Okay, so we've got a car pulling a trailer. Okay, so you can see here, I put all the forces in, the forces that we need in terms of the direction of motion here. Okay, so we've got the tractive force produced by the engine of the car. Okay, so that's pushing us forward. All right, and then when you read the question, you can see that there's a resistance on the car of 150 newtons. Also the weight component as well, yeah, because 1200 G is the weight, but the component along the inclined plane is 1200 G sine alpha. The other thing you need to consider as well is the tension, okay, in that rope, okay, or the cable that's attached to the trailer. It's actually, if you think about it, it's pulling it back, isn't it? Okay, that's a resistance as well. You know, if you were towing something, towing a trailer or towing a broken down car, it's hard to move forward, isn't it? Because of that tension in that cable is pulling you back. So that tension is sort of working against the car. Okay. Now when we look at the trailer, okay, in a way the opposite is true then, isn't it? Because the tension in that cable is pulling the trailer forward, isn't it? It's what's responsible for making that trailer go forward. So that tension is a sort of forward force there. We've got the resistance of the trailer, which is 100 newtons, and of course then the weight component. So what we can do, right, they tell us in the question that the power is 45 kilowatts, so 45,000 watts. Okay, and of course then we're asked in A then calculate the acceleration of the car and trailer when the speed is 25, so V is 25. So we know now connecting these two is that formula. Okay, power equals attractive force times velocity. So power is 45,000. Attractive force is what we're going to find out, and then velocity is 25. So basically, we can get tractive force from there. So that comes out to be 1800. Okay, so 1800 newtons. So we know now what this is. So what we can do then, of course, is apply Newton's second law. Okay, so in the direction of motion here, so we need to consider all the forces. So we've got the forward force of this engine, so tractive force, which we've worked out, so I'll substitute that in a minute. Take away then, well, the resistance of the car is 150. Also we've got the weight component, okay, of the car, and also of course the tension is pulling us back. Okay, so those are all the resistant forces acting on the car. Let's look at the trailer then. Well, you've got this tension actually pulling it forwards, haven't you? So that's a positive force there, so plus T. But then of course you've got the resistance forces then of 100 and the weight component there. Now that will equal to mass times acceleration. Okay, but if you think about it, I've applied Newton's second law here sort of to the whole system. Okay, so I'm sort of, if I'm applying it to the whole system, and I'm thinking of forward forces, take away the resistant forces, I'm thinking of it as sort of one object then, yeah? So in terms of the mass, it would be the combination of those two. So 2,000 kilograms that will be, yeah, when you add those two together. So mass is 2,000 times acceleration A there, okay? So we're thinking of it as sort of one object, okay, and that kind of like rings true then when you see this here, the tensions cancel each other out, don't they? Okay, so it's as if they don't even exist and the whole thing is connected, and you know, as if that isn't there. Okay, so it's sort of one object, so kind of works well there. So what we're going to do then, of course, is substitute in what we know. So we know tractive force is 1800. So we've got minus 1200 G minus 800 G, so that's minus 2000 G sine alpha minus the 100 equals to 2000 A. So then you can take this away here and that away, so that will be 250 there, take away, so 1550, take away 2000, G is 9.8, sine alpha is 1 over 28, and that will equal to 2000 A. So I'm just going to work that out on my calculator. So I get here 850 equals 2000 A. So an A will be then 850 divided by 2000, and that comes out to be 0.425 meters per second squared. Now in part B, it says then determine the tension in the rigid tow bar connecting the car and the trailer. Okay. Now, what we can do then is, because we actually want the tension, okay, we want the tension in that tow bar, okay, we can now just focus in, we can home in just on the trailer, for instance. So if I apply Newton's second law to the trailer, okay, so now we're not thinking of the whole system, we're just zooming in and we're focusing on just the trailer. We can forget about that. So with the trailer, if we look at the forces, well, we've got the forward force there, which is the tension, okay, take away then the 100, take away the weight component, that will equal to then the mass times acceleration. Now, of course, the mass will be 800 because we're just now focusing on the trailer, and the acceleration will be what we worked out earlier, which is 0.425. Okay, so if you substitute in then 9.8 for G, and sine alpha is 1/28, you get your tension out then to be 720.